All right, in this video, we're going to take a look at some examples of finding the exact value of inverse trig functions. Now, you could, for a problem like this, in your calculator, type in the inverse sine of the square root of 2 over 2. You might want to put your calculator in degree mode so you don't get some crazy decimal approximation for the radian answer. And then once you have your degree answer, convert it to radians. But I want to give you sort of a inside look as to what's actually going on, so to somewhat pull back the curtain as far as even what the calculator might even be doing. So we have inverse sine of square root of 2 over 2. So this is asking us, okay, what angle, if we took the sine of that angle, would give us square root of 2 over 2? Now, because it is a positive square root of 2 over 2, anytime you're taking the inverse trig function of something positive, that angle is going to be in the first quadrant between 0 and 90. So sine is y over r, opposite over hypotenuse. So here's our angle in standard position. Our opposite, square root of 2. Our hypotenuse is 2. So what angle would cause this triangle to be formed? So if we look at what theta is, inverse sine of square root of 2 over 2 is 45 degrees. So we have theta in radians is pi over 4. So if we took the sine of pi over 4, it would give us square root of 2 over 2, which is about 0.707. Part B, we have inverse cosine of negative square root of 3 over 2. So again, this is asking us what angle, if we took the cosine of that angle, would give us negative square root of 3 over 2 in return. And because this is a negative angle, cosine is negative in the second quadrant, so our angle is going to end up, the terminal side is going to end up in the second quadrant. So cosine is x over r, so we have negative square root of 3 over for x and then 2 for r. So what angle would cause this to happen? Well, in terms of theta itself, we know because it's in the second quadrant, theta has to be an obtuse angle between 90 and 180. And if we do inverse cosine of negative square root of 3 over 2, we get 150 degrees, which is 5 pi over 6. So if we took the cosine of 5 pi over 6, it would give us negative square root of 3 over 2. Part C, arctan of square root of 3, or inverse tangent of square root of 3 over 1. Here again we have a positive square root of 3, so we can sketch an angle in the first quadrant where tangent's positive. And again, it is over 1, so y over x for tangent would be square root of 3 for y and 1 for x. So what we're asking is what angle, when we draw it in standard position, has an opposite to adjacent ratio of square root of 3 to 1. And the angle that has that is 60 degrees. It's a 30, 60, 90 triangle. So 60 degrees in radians is pi over 3 radians. So in other words, the tangent of pi over 3 gives us square root of 3. All right, finally, part D, inverse secant of 2, or inverse secant of 2 over 1. It is a positive angle, it is a positive ratio here for the 2. So our angle will be in the first quadrant. So what we're asking is what angle in the first quadrant, if we knew what that angle was and took the secant of it, it would give us back a 2 in return, or r over x is 2 over 1 in return. So taking the inverse secant of 2, that's a 60-degree angle. So notice a lot of these triangles resemble or are 30, 60, 90, or 45, 45, 90 triangles in the coordinate plane. So 60 degrees in terms of radians is pi over 3. So inverse secant of 2 is pi over 3 because the secant of pi over 3 gives us 2. All right, so that about does it for this video. Thanks for watching. I'll see you next time.